Hi everyone, and welcome to this video going over lesson 17.5, classifying systems of equations. Let's get started. I would like to do a quick recap of each system that we've seen so far. So the one that we've seen the most is when we have two intersecting lines. So two lines that cross at a point, which means since they only cross at one point, we only have one solution. Another type of system that we've seen is two parallel lines. And remember, parallel means that the lines never intersect. They're going to go forever and ever and ever without crossing. And because they never cross, there's no point of intersection, which means there's no solutions to the system. And the third type of system we've seen is when we have two, in quotes, coincident lines. Because coincident lines are lines that cross through the same exact points. And so even though it's technically two, they're really on top of each other over the same line. And remember, because they're directly on top of one another, it means that they cross everywhere, and so there's infinitely many solutions. And with these systems, we are going to learn some new vocabulary words today that are going to help us put names to each of these special types of systems. So, systems that produce two distinct lines when graphed, so that's going to refer to when we have two intersecting lines or two parallel lines, are known as independent. So we have an independent system if we have two distinct lines. But systems that produce coincident lines are dependent. So if we ever have a system where they have coincident lines, that is a dependent system. Systems that have no solutions, so that's going to refer to when we have parallel lines. So systems that have no solutions are inconsistent. And systems that have at least one solution, so that's going to be either the intersecting lines, where we have one solution, or the coincident lines that have infinitely many, are consistent. So let's see if we can identify what each system is. Determine how many solutions the system has and classify the system. I'm going to start by attempting to solve the system. If I add 2x to either side of this equation, I will get y equals 2x plus 10, and then I am set up to do the substitution method, where I can plug all of this in for y, and I will get 4x minus 2 times 2x plus 10 equals 21. I'm going to distribute, or double rainbow, so I get 4x minus 4x minus 20 equals 21. But if you see here, I have 4x and minus 4x, which are going to cancel out and leave me with negative 20 equals 21, which does not work at all. And we know that when this happens, it means that there is no solution. Which must mean that if we were to graph this, we would have parallel lines, because we only have no solutions when the lines never cross. So, if we have two parallel lines, that must mean that our system is independent, because we have two lines. But because we have no solutions, that means our system is also inconsistent. Let's try another one. Determine how many solutions this system has and classify the system. I am going to add y to this side of the equation so that I have 2x plus y equals 1 and 6x plus 3y equals 3. And I notice that if I multiply this equation by -3, I can form opposites. So when I do that, my new system will be -6x minus 3y equals -3. And now I'm ready to add. But notice when I add, everything cancels out. 0 equals 0. And when that happens, I have infinitely many solutions. Which must mean that when I graph this, I will have coincident lines, where I have the same exact line graphed on top of one another. And because this is only one line, that means that my system is dependent. But because I have at least one solution, the system is also consistent. And last one, determine how many solutions the system has and classify the system. I am all set up for the substitution method, so I'm going to go ahead and plug all of this in for x. 2 times 6 minus y equals 6. I am going to distribute to get 12 minus 2y minus y equals 6. I can combine like terms, where I get 12 minus 3y equals 6. I'll subtract 12 to either side to get -3y equals -6. And if I divide by -3 to both sides, I get that y is equal to 2. But I'm not done because I still need to find x. So I'll plug this in. X equals 6 minus 2, which means that x is equal to 4. So I have one solution, which is the point 4, 2. And so this means that because I only have one solution, I must have two intersecting lines that cross at the point 4, 2. So because I have two lines, that is an independent system. And because I have at least one solution, that is also a consistent system. So to summarize, two coincident lines. Two coincident lines will mean that my system is dependent because they really only form one line. And two intersecting lines and two parallel lines will be independent because they both form two lines. And systems that have at least one solution are consistent. So we know that two coincident lines will have infinitely many solutions, so that's consistent. And we know that two intersecting lines will have one solution, so that's consistent. But because parallel lines never cross, they will have no solutions, which means this is an inconsistent system. I know that's a lot of vocabulary words, but I think that this chart is a nice summary of all of the different systems and all of their different terms. This could be something that you put on an index card for our next test. And I'm sure we're going to be doing lots of practice in class so that you can get used to the different systems and their classifications. Please let me know if you have any questions, and I will see you in class.